In the last class, we started solving problems based on unit step function. Today let's continue, but before that, please try to recollect the formulas because these are all very important. Laplace transform of A is A by S. E power at is 1 by S minus A. Cos h at, hyperbolic function, is S by S square minus A square. Sin h at is A by S square minus A square. Remember, for hyperbolic function denominator S square minus A square will be there because in the formula it's a combination of e power at and e power minus at. So A plus B into A minus B, A square minus B square. That is why denominator S square minus A square. Whereas cos at is S by S square plus A square and sin at is A by S square plus A square. Laplace of t power n is gamma of n plus 1 by s power n plus 1, and this is a particular case when n is 1, 2, 3, it is n factorial by s power n plus 1. And now coming to the properties, if I know Laplace transform of f of t, I can guess Laplace transform of e power at f of t. So that is nothing but f bar of s minus a. So what we will do, I will find Laplace transform of this function f of t. Wherever s is there, I will replace it by s minus a. And then Laplace of t power n into f of t. And this formula is minus 1 power n d power n by ds power n of f bar of s. So what I will do, I will write Laplace transform of this function and then differentiate n times. So this t power n will tell you how many times you have to differentiate. And outside we have minus 1 power n. This is property 2. And then coming to property 3, if I know Laplace transform of f of t, I can guess Laplace transform of f of t by t. So the formula is integral s to infinity f bar of s ds. These are the three properties. And then we studied Laplace transform of periodic function. Remember, this capital T is nothing but period. So 1 by 1 minus e power minus s capital T integral 0 to capital T, and these are all normal function e power minus st f of t dt. And then finally in the last class we started studying about unit step function, and we know what is unit step function. It is 0 from 0 to a, and from t greater than a the function is always 1. That is why 1 is nothing but unit, right? So always we call it as a unit step function or heavy side function. And then coming to the properties, this is the first property, L of u of t minus a is e power minus as by s. This is the first property. And L of f of t minus a into u of t minus a is e power minus as into f bar of s. We did problems based on this in the last class. So what I will do, this is if it's u of t minus a, the function next to it is nothing but f of t minus a. From this I will find f of t. Okay, wherever I will replace t by t plus a or t minus a, whichever is required according to this. We will change it and find f of t and find Laplace transform of that function, and finally we will multiply with e power minus as. And now coming to discontinuous function, that is if f of t is equal to, say, function, first function f1 of t from t less than or equal to a, and second function f2 of t from t greater than a, then we have this property. See, if this is the function, then f of t is equal to my first function f1 of t plus second function minus first function f2 of t minus f1 of t into u of t minus a. This is the third result. So first we have this Laplace of u of t minus a is e power minus as by s, and second one is this, we have done problems based on this. And third one is if it's a discontinuous function, then I have to write it like this. So f of t is, write the first function f1 of t as it is plus second minus first, that is f2 minus f1 into u of t minus a. Now we know how to find Laplace transform for this function. After this step, it's just the previous property. Let's see problems based on this. See this problem, f of t is equal to sin t from 0 to pi and 0 for t greater than pi. So what we will write, first function f of t, first I will write this. What is my first function? Sin 2t plus second minus first, 0 minus sin 2t into u of t minus pi. This is what we have written. In the property we have written t greater than a. So we wrote t minus a. Here in the place of a I have pi. So we have written t minus pi. After using this property, then it's simple. We are going to take Laplace transform for this function. So L of f of t is Laplace of sine 2t. We know what is Laplace of sine 2t. It's a direct formula, minus Laplace of sine 2t into u of t minus pi. Now this problem is similar to what we have done in the previous video. So it's just a continuation. Only this line is new for you, and then after that it's the same old procedure. So what we will do, along with u of t minus pi, whichever function is there, I will write it as f of t minus pi. So f of t minus pi is sine 2t. So if this function is sine 2t, then I will find what is f of t. So wherever t is there, I am going to replace it by t plus pi. So when, see, very simple, when this term will become t, when t becomes t plus pi and minus pi will get cancelled and I will get back t. Okay, so we are going to replace t by t plus pi. So sine 2 into t plus pi. So sine 2t plus 2 pi, you are just multiplying inside. 2 pi is 180. So sine of 180 plus theta. Okay, so 180 plus theta means, yeah, actually it is 180 into 2, right? So it is 360. So 360 plus theta means it will come in the first quadrant, all are positive. So I will get sine 2t. So f of t is nothing but sine 2t, and we are going to find f bar of s for this. What is the formula for sine at formula? A by s square plus a square. So 2 by s square plus 4. So this is f bar of s. So we are using the same formula. Laplace of f of t minus a into u of t minus a is equal to e power minus as into f bar of s. In the place of a we have pi. So e power minus pi s into this answer, 2 by s square plus 4. So only the first line is different, and after that everything else is the same. And see here, the same problem solved by using the direct formula method. Laplace of f of t is e power minus st into f of t dt, and then using e power at sin bt formula, we will get the same answer. So we are using the formulas to get the answer little faster as well as easier. Now let's see one more problem. F of t is equal to sin t in the interval 0 to pi by 2 and cos t for t greater than pi by 2. So how we will write the function f of t? First function, that is sin t plus second minus first, cos t minus sin t into u of t minus pi by 2. Here we have t greater than pi by 2, so t minus pi by 2 we have to write. So this is a property. And then we are going to apply Laplace transform on both sides. So L of f of t is nothing but L of sin t plus L of the whole second term. After this, this is again one more property. So what is this? F of t minus a into u of t minus a. That is a property. In the place of a we have pi by 2. So the whole thing, that is other than u of t minus pi by 2, all the terms we will write it as f of t minus pi by 2. So we have written like this. So f of t minus pi by 2 is cos t minus sin t. This is direct formula. What is Laplace of sin t? That is Laplace of sin at, correct? What is the formula? A by s square plus a square. So 1 by s square plus 1. This is the Laplace transform for sin t that we have written in the final answer directly. Now we are finding the Laplace of this term. So we have written what is f of t minus pi by 2. So what we want actually f of t. So in the place of t, what should I substitute to get only t? So what I will write, t plus pi by 2 minus pi by 2. So this and this will get cancelled, I will get f of t. So we are replacing, wherever t is there, replace it by t plus pi by 2. So right hand side will become cos of t plus pi by 2 minus sin of t plus pi by 2. That is what we have written. And then 90 plus theta. So 90 plus theta, which quadrant? Yeah, this is 90. So 90 plus theta means this quadrant sin is positive, correct? So here cos we have. So if it's cos, I will write sin, and only here sin is positive, we have cos here, so minus sin t we have written. Minus sin will become cos, and this minus sign only we have written. In this quadrant, sign is positive, so I didn't change the sign. This sign is already there, so sine of 90 plus theta is cos theta, and cos of 90 plus theta is minus sin theta. So this formula we have applied, and now we are going to find the Laplace transform of f of t. So we got f of t minus pi by 2, we found what is f of t. Now we are going to apply the formula. Laplace of sin t, 1 by s square plus 1, this negative sign is there already, minus Laplace of cos t, s by s square plus a square, cos 1t, right? So s by s square plus 1. Here the denominator is common, so s square plus 1 if we take common, a negative sign is also in the numerator, so minus of s plus 1. So this is the answer for this second term. And Laplace of f of t minus a into u of t minus a, what is the property? E power minus as into f bar of s. So in the place of a I have pi by 2. So e power minus pi by 2 s into f bar of s. F bar of s is this answer. So we have written this, and finally we are writing Laplace of f of t. So this part, Laplace of f of t minus a into u of t minus a. If you are getting confused, just go to the previous video, again solve the problems on your own and then come back. Then it will be easy for you. And let us see one more problem. F of t is equal to 1, 0 to 1, first interval, t 1 to 2, second interval, t square, t greater than 2. Okay. Now try to write f of t on your own, check the answer and then solve it. Okay. So first we will write the first function 1 plus second minus first, so t minus 1 into u of t minus 1, then last one t square minus t into u of t minus 2. This is the property. So when you are writing here, you have to concentrate only on this t greater than what. Okay. So we are writing the first function because that is 1 as it is. Then second function minus first function, t minus 1 into u of this thing, right? We are writing t greater than 1, so we have written t minus 1. Again t square minus t, second term minus the previous, third term minus the previous term into u of, see this t greater than 2, so I have written u of t minus 2. When you are writing this, you have to check on the interval t greater than what. Here t greater than 1, so I have written u of t minus 1. Here t greater than 2, I have written u of t minus 2. Now you can continue. This is very easy. What is Laplace of 1? Laplace of 1 is 1 by s, correct? So that is not at all a problem. Now we have to find Laplace of this term and this term separately. So since this is u of t minus 1, along with that whichever term is there, this is nothing but f of t minus 1. So f of t minus 1 is t minus 1. This is very easy. So replace t minus 1 by t, correct? So automatically you are getting the answer. So eventually what we will do, replace t by t plus 1. When you replace t by t plus 1, what you will get? Plus 1 minus 1 will get cancelled, you will get only t. So here also t plus 1 minus 1, so that is why we are getting t. And in the second function, u of t minus 2 is there. So t square minus t is, already we have written f, you can write f1 or some other name. So this is g of t minus 2, whatever it is there, I will write that function. G of t minus 2 is t square minus t. So we are going to find g of t. So replace t by t plus 2. So what I will get here? T plus 2 minus 2. 2 and 2 will get cancelled, g of t. Right hand side, t plus 2 the whole square minus t plus 2. So a square plus b square plus 2ab. T square plus 4 plus 2 into t. And then here minus t minus 2. So simplify the terms, you will get this. T square plus 3t plus 2. So we got g of t. So now we have to find f bar of s and g bar of s. This is very easy because t power 1, what is the formula for t power n when n is equal to 1, 2, 3, etc.? It's n factorial by s power n plus 1. Here power 1 is there. So 1 factorial by s power 1 plus 1, 1 by s square. And this term t power 2, 2 factorial by s power 2 plus 1. So 2 by s cube. Plus 3 into 1 factorial by s plus 1. Same thing, 3 into 1 by s square. Plus 2, this is just a constant term. Laplace transform of 2 is 2 by s. So simultaneously we are solving both the problems. If you are getting confused, solve only the first one, write down the answer and then go for the second one. So now finally we are going to substitute all the values over here. So find this Laplace for this function. So this is L of f of t minus 1 into u of t minus 1 by the property e power minus as into f bar of s. Correct? So here in the place of a 1 I have, so e power minus 1s into f bar of s. So e power minus s into what is f bar of s? 1 by s square. So e power minus s by s square. So we got for the first function. Now we are going to find it for the second function. Since we named this as already as f, we named this as g. Okay. So L of g of t minus 2 into u of t minus 2 is equal to e power minus as into g bar of s. So in the place of a I have 2. So we have written e power minus 2s into g bar of s. So what is g bar of s? Just now we have calculated. So e power minus 2s into 2 by s cube plus 3 by s square plus 2 by s. We have written this. Okay. So now we have to finally substitute. Laplace of 1 is 1 by s. Done. Laplace of this term, just now we have calculated e power minus s by s square. Done. Then Laplace of this term. So we have written. We have to be very careful with this, what I have to write here. You may get confusion here, what I have to write, u of t minus 1 in both the term. No. Here you are going to check t greater than what and you are writing it. And second thing, when you are whatever formulas you are using, please write down. Here we have used Laplace of t power n, we didn't mention it, by using formula and write down the formula. Here also by using property L of f of t minus a into u of t minus a is equal to e power minus as into f bar of s. Write down that property and then solve these problems. And now I am going to leave these two problems on your own to practice it. You can take a screenshot and check the answer later. Here the function is cos t 1 sin t. So when you are writing first function cos t plus second minus first, 1 minus cos t into t greater than what? Here t greater than pi. Don't see 2 pi. Here t less than. So you are going to compare pi less than t. It is same as t greater than pi. So you are writing u of t minus pi. Same way sin t minus 1. Here t greater than what? 2 pi. U of t minus 2 pi. Once you are done, you can apply Laplace of cos t formula, s by s square plus 1 square. This is very easy. Here this is one separate term. This function you can take it as f of t minus pi, and this you can take it as g of t minus 2 pi. So here t minus pi is there, so I am writing this as f of t minus pi. Here t minus 2 pi is there, so I am writing this as g of t minus 2 pi. And then from here we are going to shift and find what is f of t. So replacing t by t plus pi, we are getting this. Simplified 180 plus theta and all those things. Here g of t minus 2 pi is this. So g of t is, you are replacing t by t plus 2 pi. So right hand side you will get this. Again 2 pi is nothing but 2 into 180. So sin 360 plus theta. Again first quadrant all are positive, sin t. So once you got f of t, this is very simple. Laplace of transform 1 is 1 by s. Cos t is s by s square plus 1, because already we have used it. Sin t is 1 by s square plus 1, and then 1 is again 1 by s. And finally we are using this property L of f of t minus pi into u of t minus pi is e power minus as into f bar of s. Similarly, in the place of a, in the first term I have pi, in the second term I have 2 pi. Finally you have to substitute the answer. Check the answer, solve it on your own, and finally correct the answer. And this problem also you can try later and have a look at it. This is very simple, but still. with only two functions, that is e power t 0 to 1 to t greater than 1, e power 2t plus 2 minus e power t into u of t minus 1. And then e power at formula we will be using it, and same property. Please mention the formulas as well as the properties that you are using for the current problem. Thank you.